Hi there, my name is Poulis. I'm working at the Adhesion Institute of the Delft University of Technology, and I will take you on a little journey on the influence of loading and temperature on adhesives for lining canvas paintings. This is what a canvas painting generally looks like. You have the canvas, the sizing, the ground layer, which is usually white, and the paint layers covered with or without a varnish. However, if the painting becomes older, it might need conservation. And in this case, we might use a new canvas which will be glued or adhesively bonded to the original painting, as you can see in this slide. The Adhesion Institute was involved in the conservation of the Panorama Mesdag in The Hague in the early 1990s. And I will show you a little film which shows what the original painting looks like.
In 1881, Hendrik Willem Mesdag painted a panorama of Scheveningen just as it looked at the time. The old fishing village, the beach with fishing boats drawn ashore, and the seaside just starting to become fashionable. Since then, thousands of people have come every year to admire this unique view. More than 100 years passed, and the canvas inevitably deteriorated. Exposure to sunlight, extreme changes of temperature and humidity, leaks and other problems damaged not only the work itself, but also the material on which it was painted.
30 years later, I wondered what the influence of the temperature would be on very often used lining adhesives. So we started out with glue paste, which is a collagen-based adhesive containing wheat starch. We tested wax resin, which is a proportional mixture of beeswax and terpenoid resins. We also used the original formulated BIVA 371, which is a mixture of 2 EVAs, a plasticizer, a tackifier and a wax. And eventually we also tested a aqueous mixture of 2 acrylics, the Plextol D540 and the K360. But we started off with DSC to find out what the performance as a function of temperature of these different adhesives would be. The first thing that you see when you look at this table is that wax resin is in an amorphous state. And the second thing that you will notice is that the animal glue paste has the highest melting temperature and the highest TG. This means that actually we're working on at least partly a crystalline phase during our testing. Then we have the BIVA, which melts at around 60 degrees C with the original formulation, and later on it became about 65 degrees C. This is the first test, an example of the first tests that we did, lap shear joints, to determine the strength of the adhesives as a function of loading. What you see again is these lap shear joints with the canvas shown in brown and the adhesive bond shown in blue, and we tested them accordingly by loading them into one direction. The creep samples look very familiar to the ones that were shown in the previous slide, the lap shear joints. However, what we can see here is 3 adhesive bonds in series. So we measure 3 adhesives at the same time, 3 adhesive bonds at the same time. And this is what it looks like in real life. You see the canvas material and you can see the adhesive bonds around there. And this is the creep test setup. You see the laser, which is shown in black, which is linked to a computer, and every minute it takes a measurement. There's 2 clamps, one on the left hand side and one on the right hand side. The one on the right hand side, this one, is functioning at the same time as a mirror for the laser to determine the creep as a function of time. This is a photograph showing a canvas which is mounted into the setup, and the laser can be seen here as a black little box.
The Aerospace Engineering Department at Delft University built a replica of a section of the panorama. It provided an excellent testing ground for the restorers and gave them a chance to solve whatever problems might arise in the actual relining process. They found that the best way to attach the new canvas to the old was by applying thermoplastic glue and creating a vacuum between the 2 sheets. Everything depended on using the right kind of glue. It had to be strong enough to adhere to the canvas, but they also wanted to be able to reverse the procedure, if necessary, without damaging the original canvas. They ran tests using strips of canvas to see how much glue they needed to apply.
Now we come back to the present time and look at the other measurements that we did besides DSC. Here we see a graph of the stress-strain curves. We can see that the glue paste adhesive, as we expected, shows a very good performance. It has a very high strength. The second best might be the Biva, with also large strain before it fails. And what you can see is also the Blackstall, which performs as the weakest adhesive. And we have to keep that in mind when we come back to the conclusions. Looking now more closely at the experimental creep test results, and we compare the strain as a function of time for 3 different temperatures of one adhesive, in this case the Blackstall, we see that the black one, which is the room temperature one, shows much less creep as a function of time than the one tested at the highest temperature at 45 degrees, which is the blue one. And the 35 degrees is clearly in between the 2. When we look at one of the other adhesives, which is in this case the glue paste, and again we look at the strain as a function of time, we can see that the black line, again room temperature, shows the least strain as a function of time compared to the highest temperature, the blue one. If we combine all the test results, we find that especially glue paste doesn't show, even at the highest loading of all, which is shown in the second column, it doesn't show any failure during the tests. This means that as a mechanical engineer, I would be pointing out to this adhesive as being the best, even at the highest load. However, that's not the case if we take the reversibility in our mind. So coming to our conclusions, 4 types of adhesives have been tested, and the temperature seems to have a large influence on the mechanical behavior of all these tested ones. At museum conditions, so at room temperature 25 degrees, 50% relative humidity, glue paste and Biva provide a very good adhesion and a high bond strength. However, when we consider the temperature that is needed to apply Biva and the pressure needed to press the new canvas to the existing old canvas, we could ask ourselves the question if this is the best adhesive, especially when we consider reversibility, because it's difficult to get the material out afterwards. Glue paste shows the best overall performance. However, if we apply glue paste, we also introduce a lot of water, which generates swelling in the canvas and also might interfere with the original glue paste used in the sizing. So that's a very difficult point if you want to restore a painting. It might have large interference with the original painting, and it's difficult to get it out afterwards. Then we have the wax and the plextal. Wax was originally used for relining. However, you need again high temperature and pressure to get it into the old canvas and into the new canvas. The whole old painting will be soaked with this wax material, which is not a very good thing because you can never get it out again. That leaves us again with the plextal, which performs as the weakest adhesive. However, if we consider reversibility, it might be one of the best choices, especially when we apply it with a mistlining technique. I would like to thank you for your attention, and I highly appreciate the input of both Yasmine Mosleh and Kate Seymour from Strahl. Besides that, a lot of work has been done, especially by Lena Wesselink. She did a lot of these tests that I just showed you. And of course, all the people from our laboratory, the laboratory staff who made the test setups.